We're going to be playing around with this simulated circuit. And I'm going to open it up and just show a little bit how this works. So we have some elements that we can just drag over and create a circuit. Let's start with a battery. So I'm just going to, it didn't work. Oh, okay. So yeah, you can just grab it, pull it onto the screen. And here it says tap circuit element to edit. So if we tap this, we can see the voltage anywhere from 0 to 120 volts, say 25 volts. You can move it around and rotate it as well. And let's make a very simple circuit. And we'll have just, say, 3 resistors and 2 of them in parallel. And it helps to just get all the elements set up first and then add the wires at the end. So let's put some resistors here. Let's do this. Let's just drag this over. We'll have these 2 on the right. We'll have these 2 in parallel with each other. And then just connect them with wires now. So we'll hook up these 2 in parallel. This one will be connected right to the battery and then go to this combination. We can put the switch anywhere in the circuit. In circuits like this, the switch doesn't really matter anyways. But let's now connect it with the wires. So I'm going to drag this wire here, and if you do this, it'll connect to that element. Then the other end we can move around. So let's do that. And here I want to connect this to the resistor. So this end is connected. Now I can grab this one and pull it over. And kind of really easy once you start working with this to kind of see how it works. So there's one loop, and then we can do this. I mean, I guess we could just connect it directly, but to make it look nice, we like drawing these in a nice rectangular way. And it could make a difference if we click here. We can give the wires some resistance and the battery some resistance. Maybe we should do that. So the length of the wires will matter a little bit. But to be realistic, let's make the wire resistance very small. Okay, so we have a simple circuit here. Now, if we close the switch, we can see the electrons moving. And like this is the positive terminal of the battery, so we know the current is going to be flowing clockwise. But the electrons are moving counterclockwise, and of course that's because they're negative charges. So here it says show current, and we have the electrons selected. We could switch to a conventional current, which shows like the direction charge is flowing. And so that one is moving clockwise from positive to negative. Oh yeah, if you click on, if you want to break the circuit here, we could undo a connection if we want. Okay, so yeah, it's very simple to use this. You just drag things around and click them together. We could add more. Oh yeah, let's just turn the current off for now. So now the values, yeah, we gave the battery an internal resistance. And the values are all 10 ohms for the resistors. Well, we can change that by just clicking on them. Okay, so again. Now, what we might want to do though is measure, like, we have this circuit. We want to know, like, what's the voltage drop across a certain element. Current again. Yeah, like what's the voltage drop across certain element? How much current is flowing through a particular branch? And this is where maybe it would have been better if we thought about how we're going to measure these. Well, the voltage, we have a voltage meter here. We can just drag this over and leave it anywhere. So like we measure voltage in parallel with the element. So we can just put these probes, like if we want the voltage drop across this 72 ohm resistor, we can having a little interference. Cat decided to hang out right in front of the computer. Okay. And right now the switch is open, but if we close it, we can see the voltage drop here is 8.77 volts. We want the voltage drop across here, should be basically the same, 8.80. It's not exactly the same because, this branch is a little bit longer. So, like from here to here, the voltage drop has to be the same. But this one has a little bit more resistance in the wires. That's why the voltage drop across this one is a little bit less. Not much. And the voltage drop here. So we could like check the loop rule. If you flip these around, we get a negative voltage. But in this case, it doesn't really matter. If you accidentally measure a negative voltage, just ignore it. Call it positive. Now, so measuring voltage is easy. We just need 1 voltmeter and we can adjust the probes as needed. Measuring current is a little more tricky because we have to actually put the ammeter, it's called an ammeter, measures amps. We have to actually put that in the circuit. And let's say we want the current everywhere. So I want to put an ammeter in each branch. It should be roughly the same on top and bottom because we have a junction here, so the current's going to split up and then they'll rejoin here. Why don't we do it? We'll put 4 ammeters in. I'm going to move this over a little bit. Switch over a little bit. So we'll put an ammeter here, here, and in these 2 branches. Let's kind of drag this down to make it make room for it. So let's do that. Let's break these connections here. So we have room to add these ammeters. And then we'll add more wires. So like right now, I don't care what that looks like. You can always adjust that later. Okay, so now we can measure the current in these 2 branches. And we'll put one here, so we have to cut this connection. And let's cut this one as well. So let's shorten these wires. So again, maybe when you're doing this in the lab, instead of setting it up and then adding the ammeters, maybe think ahead a little bit and just build them in before creating the connecting wires. That would make things a little bit easier, but not a big deal either way. Okay, so right now the ammeters are all reading 0 because the switch is open, so nothing can get through. I'll make it somewhat rectangular. And now let's close the switch and look at the currents. So I'm saying that the top and bottom should be roughly the same. Let's see. Yeah, they're the same. So yeah, current splits up and then they recombine. So yeah, just that's the main problem with these simulations is that there really aren't any errors. And so our numbers work out too nicely, if anything. But yeah, we have 0.43. Okay, maybe they don't work out perfectly though, because if you look at this junction here, we have 0.43 amps coming in, And if we add up the current in these two branches, it looked like 0.42. So it looks like there's some missing current. Again, it's just this internal resistance of the wires. And yeah, we can always, measure the voltage then anywhere we want. We just need 1 voltmeter for the entire lab. We can move that so that the wires don't get in the way of the reading. And so, yeah, that's basically how this works. It's real easy once you just start playing around with things. Then you can do some kind of, let's change the voltage here. I wonder if there's limits. Like if we can fry the circuit or something, if we, yeah, it's kind of like these arrows actually. We can see that, these arrows are moving. The more current, the faster they're moving. So like when there's current going into the junction, it has a choice. Which way does it want to go, right? Or does it want to go through this branch or this branch? Well, this one has more resistance, so more current's going to flow this way. You can see like these arrows are moving faster through here and getting backed up here. And, oh yeah, let's unclick that. That was kind of blocking things. See what else we can do. Oh yeah, I want to see if we can like fry this circuit. Yeah, so if we lower the resistance down to say like 4 ohms, a lot more current's going this way. Very high resistance in this branch. So we can effectively block the current flowing through this circuit almost entirely. And again, that's kind of how voltmeters work. They're measured in parallel. So there has to be some current flowing through the voltmeter itself. But the voltmeter is designed to have a very high internal resistance. Because by diverting this current through the voltmeter, we're actually changing the circuit that we're trying to measure. So they have a very high resistance to prevent that from happening. Yeah, let's just lower it overall. The resistance everywhere. See how high we can get these currents. Like I wonder if we, like in a real circuit, oh yeah, so now things are starting to burn. The battery, and yeah, you can very easily fry things in a real circuit if you don't have much resistance. And we've exceeded the speed limit of the simulation, so it had to slow things down. Not sure if anything's going to happen with this fire they're showing. Okay. So, and then there's other things. It's like a dead battery, a fuse. Now, actually, let's do this. Cut this. So we noticed that we had fire in our circuit. Isn't usually a good thing. And so to protect our circuit, we can put a fuse. And let's try now. So the circuit's working just fine. This fuse, it has less than or equal to 4 amps. So like right now we have 1.84 amps. Let's lower the resistance. Oh, so our fuse broke basically. You can see as we are lowering the resistance, the current was increasing, and eventually the current exceeded 4 amps and the fuse broke. Get rid of these values. So you can see there's a thin wire inside this glass tube, and if the wire gets too hot, it breaks, and that kills off the current. And so that's a way to protect your circuit. Like this fuse was designed to break at 4 amps, and so if you have some delicate instrument in your circuit that too high of a current is going to damage it, you can protect it with a fuse so that once the current reaches that value, it just kills the current, and then everything goes out. So you'd have to actually fix it at that point by replacing the fuse, but it prevents any permanent damage. Coins, erasers, pencils, a dog. Put a dog in our circuit for some reason. Let's just get rid of this. All right, let's put a dog in the circuit. Okay, didn't like that. I guess that's maybe too much current for him. Okay, I guess if you don't have a fuse, you could use a dog. That seems to serve the same purpose. All right, let's not. Okay, so we have a dog. He's just watching things now. Okay, so yeah, that's it. So we can make these circuits. We can measure current and voltage using these instruments here. We can add some resistance to the wires and the battery to make things more realistic. And add some other things like fuses or pencil. Pencils would work. You could heat them up and actually cause them to light on fire. Paper clips are conductors. But yeah, we'll stick with the basic stuff. Looks like that's a dead battery. Oh yeah, light bulb. Let's put a light bulb in the circuit as well. Put it here. And yeah, the more power we deliver to the light bulb, the brighter it gets. So let's lower the resistance here. Not getting. Okay, let's raise it. I think it's kind of at maximum brightness. Let's lower the voltage and see what happens. Yeah, the brightness goes down. So we can kind of measure. Let's see if it shows values for that. Oh, there's 1,000 ohms there. So we can calculate the power delivered to the light bulb and see how that affects the brightness. All right. So again, the purpose here, not going through the actual lab we're going to be doing, just putting, showing how this simulation works and how we can put things together. And then in the actual lab, you'll have a particular circuit and kind of to know how to figure this out pretty quickly. And again, it's very easy to do. So I'll leave this here, and yeah, that'll be it for this recording.